Hello everyone, in this video we're going to learn how to solve square root inequalities. Alright, if both sides have the variables, you have two types right here. Type number 1, square root of f of s less than g of s. Then, in order to solve this one, you need to find the domain. G of s must be greater than or equal to 0. F of s must be greater than or equal to 0. Then you're going to square both sides. Now, type number 2, square root of f of s greater than g of s. Then, in order to solve this one, you have two different cases. Case number 1, f of s greater than or equal to 0, g of s less than 0. Case number 2, g of s greater than or equal to 0. Then, you're going to square both sides. Now, if one side has the variable and the other side just a constant, in other words, the one under the radical side right here has the variable. The first step you need to do is to find the domain of this guy. So it's going to be a greater than or equal to 0, right? Now, step number 1, you need to rewrite the given equation in this form or this form. Step number 2, you need to find the domain restriction. Step number 3, isolate the radical. Step number 4, solve for s. Step number 5, make a conclusion using the domain. Example number 1, we need to isolate the radical, right? So I'm going to add 6 both sides. So it could be 2 square root of 2s plus 4 greater than 8, right? Divide both sides by 2. So it could be square root of 2s plus 4 greater than 4. I need to find the domain, right? So domain is going to be this guy right here greater than or equal to 0, right? So it could be 2s greater than or equal to negative 4, s greater than or equal to negative 2, right? Now I'm going to square both sides, right? So it could be 2s plus 4 greater than 16, right? Subtract 4 both sides, so it could be 2s greater than 12, right? Divide both sides by 2, so s greater than 6, right? Now we're going to compare with the domain right here. We have s greater than 6, which is always greater than or equal to negative 2, right? So your solution should be s greater than 6 or from 6 to positive infinity. This guy is your final solution, right? Now example number 2 is exactly the same thing as example number 1, right? So we need to isolate the radical, right? Now we need to subtract for both sides, right? So we have negative 2 square root of s minus 3 greater than negative 4, right? Divide both sides by negative 2. So you have square root of s minus 3 less than 2, right? Then we're going to square both sides. So we have s minus 3 less than 4, right? Add 3 both sides, so s less than 7, right? Now we need to find the domain, right? So domain, which is this guy right here, greater than or equal to 0, right? Then we're going to add 3 both sides, s greater than or equal to 3, right? Now we're going to combine this guy and this guy. So your solution should be 3 less than or equal to s less than 7. Or you can write bracket 3, comma 7 parentheses. Either way works, right? Now example number 3, we're gonna add 8 both sides. So we have negative 1 over 2 square root of s minus 5 greater than 8, right? We're gonna multiply both sides by negative 2. So we have square root of s minus 5 less than negative 16, right? Now we're not gonna square both sides because the square root of s minus 5 right here cannot be a negative number. So we have no solution, right? Now example number 4, we're gonna subtract 2 both sides, right? So we have 2 square root of 3 times s minus 4 greater than or equal to negative 1, right? Divide both sides by 2. So square root of 3 times s minus 4 greater than or equal to negative 1 over 2, right? This one always true, right? Now we need to find the domain. So the domain of this one should be 3 times s minus 4 always greater than equal to 0, right? Now we're going to divide both sides by 3, so we have s minus 4 greater than equal to 0, right? Add for both sides, so s greater than equal to 4, right? Now we're going to combine this guy and this guy, right? So final solution should be s greater than equal to 4 to satisfy the domain right here and satisfy this one, right? Example number 5 is slightly different from example number 1 through 4 because both sides have variables, right? And we look at this one, it's going to be less than, right? So we're going to use the type number 1 right here, right? So ls greater than equal to 0, GLS greater than equal to 0, and we square both sides, right? So this guy is the same thing as 3 plus 3s plus s squared greater than equal to 0, right? 2s plus 1 greater than equal to 0. And we square both sides, it's going to be 3 plus 3s plus s squared less than 2s plus 1 altogether square, right? We're going to use complete square formula to expand this one. Remember, we have a plus b altogether square equals a square plus 2ab plus b square, right? So this guy is the same thing as 4s square plus 4s plus 1. Now I'm going to solve the system of three inequalities, right? So for the first one, I need to rewrite this one as a complete square, right? So I have s square plus 3s plus the third terms right here plus 3 greater than equal to 0, right? Now in order to find the third terms right here, I'm going to take the coefficient of the middle term right here, divide by 2 and square, right? So it could be 9 over 4, right? Then you need to subtract 9 over 4, right? Now for the second one right here, s must be greater than equal to negative 1 over 2. And the third one right here, subtract s squared both sides, so it could be 3s squared. Subtract 3s both sides, so it could be plus s. Subtract 3 both sides, so it could be negative 2 greater than 0, right? So this guy is the same thing as the first three terms right here, actually the complete square formula right here, right? So it could be s plus 3 over 2 altogether square. Now I'm going to simplify this guy, right? So it could be 3 over 4, right? Greater than or equal to 0. The second one, just rewrite it as greater than or equal to negative 1 over 2. Now the third one right here, we can use as method to factor this guy out, right? So I have negative AC, which means negative 6, and this guy 1. Find two numbers multiplied for negative 6 add up to 1, which is 3 and negative 2, right? So this guy is the same thing as s plus 3 times s minus 2. Then you need to divide by coefficient right here. It could be 3 right here, greater than 0, right? So s plus 1 times s minus 2 third greater than 0, right? Now we have 2 0. The first one is negative 1. The second one is 2 third. Put these two guys on the number line, right? Negative 1, 2 third, right? Now I'm going to check the interval, right? So I'm going to pick a 0 right here within this interval, right? I substitute over here. So I have the 0 plus 1 times 0 minus 2 thirds is going to be negative, right? So this interval is negative, and you keep changing the sign, so this is positive and this is positive, right? Now you need the inequality greater than 0, right? So the interval should be from here to here and from here to here, right? So it's going to be s less than negative 1 or s greater than 2 thirds, right? Now we're going to check the first one right here is actually true, right? because a square of a number plus 3, 4 always greater than equal to 0, right? Now second one, s greater than equal to -1 half, and we need to combine with this guy and this guy, right? If you combine this guy and this guy right here, it's actually no solution, right? Because you cannot find a number that greater than equal to -1 half and less than -1, right? Now, if we combine this guy and this guy, and then your solution should be s greater than 2 thirds, right? And this one is your final solution that satisfies the first one, the second one, and the third one, right? Now, example number 6. This guy is type number 2, right? Right here. You have LS greater than equal to 0, GOS less than 0, right? So we need 8 plus 2s minus s squared greater than equal to 0 and 6 minus 3s less than 0. Now for the first one, I just multiply both sides by -1. So this guy turns out to be s squared minus 2s minus 8 less than equal to 0, right? The second one, I just solve for s, so we have -3s less than -6, right? Now, the first one, I just factor this one out. So I'm going to use S method. A times C, which means -8, right? B, which means -2. I need to find two numbers multiplied equal -8 add up to -2, which is -4 and 2, right? So the first one becomes S minus 4 times S plus 2 less than or equal to 0. The second one, divide both sides by -3, so s greater than 2. Now I need to find the 0 of this one is actually 4. The 0 of this one actually -2, right? I put this guy on the number line. -2 and 4 right here, right? Now I'm going to check the interval, right? So I pick 0 over here, substitute 0 for s back over here, right? So I have 0 minus 4, 0 plus 2. When you multiply them, it's going to be -8, which is negative, right? So this interval is negative, and this guy positive, this guy positive, right? Now you need the inequality less than or equal to 0, right? So it should be from here to here only, right? So this guy is the same thing as -2 less than or equal to s less than or equal to 4, right? You need to include the endpoints because you have the equal sign right here, right? And the second one, s greater than 2, right? We put these three guys on the number line, right? So we have -2 right here, 2 right here, and 4 right here. Now the first one should be from here to here, right? The second one, we only need s greater than 2, so which means from here to here only, right? So your final solution for the first case is from 2 less than s less than or equal to 4, or you can write 2 comma 4, and this is the bracket, right? Now case number 2. Set minus 3 s greater than or equal to 0, then we square both sides, so it could be 8 plus 2s minus s squared greater than 6 minus 3s altogether squared, right? So this guy is the same thing as -3s greater than or equal to -6, right? And we're going to use complete square formula to explain this one, right? So it could be this guy is the same thing as s less than or equal to 2, right? And this guy, we just add s square both sides, it could be 10s squared, right? Subtract 2s both sides, it could be -38s, right? And subtract 8 both sides, it could be plus 28 less than 0, right? Now for the second inequality right here, I just divide both sides by 2. So it could be 5s squared minus 19s plus 14 less than 0. Now I show you a trick how to solve this inequality faster, right? A equals 5, B equals negative 19, and C equals 14. Observe that A plus B plus C equals 5 minus 19 plus 14 is going to be 0. You have two solutions. S1 equals 1. S2 equals C over A, which is 14 over 5. So we put these two guys on the number line. 1 right here and 14 over 5, right? Now we're going to check the interval. So I pick 0 right here, substitute back to the inequality right here, right? So I get 28, which is positive, right? And this is negative, this is positive, right? Now I need this guy to be less than 0, right? So only this interval satisfied, right? Your solution for the second inequality right here should be 1 less than s less than 14 over 5, right? I need to combine this guy and this guy right here. So I'm gonna draw the number line one more time, right? So I put 1 here, 2 here, and 14 over 5 here, right? Now this interval, which is from 1 to 14 over 5, right? And this interval right here, which is less than or equal to 2, right? So it can be from here to here only, right? So if you combine these two guys right here, your answer must be from here to here, which is 1 less than s less than or equal to 2, right? So your final solution should be 2 to 4 union 1 to 2, right? And then if you combine these two guys, it's actually from 1 to 4, right? This one is the final answer, and it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.